Well folks, it's the Thursday before Easter. That means it's Maundy Thursday. This week's very busy for me, bearing in mind I work as a church organist, and as we lead up to Easter, I had a funeral to do yesterday, and of course most of the time that's available for work, other than the church work, is on my own Fortune Andrews organ in our private chapel here. And things are happening. I'm about to get that bellows, which has had about 800 hours work done on it. We're in a position where probably tomorrow we'll actually connect a blower up to it. I've blocked off all the outlets and we'll see whether it's full of wind leaks. Now this has come from Mike, who sends one or two in. Looks like somebody's put a hefty bridge rectifier there instead of the normal arrangement of the power supply. Wonder why they would do that. And the radio needs 1.2 amps and the power supply is capable of 2, so so we've had a look round. So we've got a Harvard H407 base station in jolly good condition. H407, did I say H407? Uses Cybernet 002 chassis, which is also used in the genuine Amstrad version. I know people call it the Amstrad chassis, but it isn't the Amstrad chassis. So we'll open this up. I once had a screwdriver that came with a Nissan car, or was it a Datsun car? We're going that far back. And it fitted these CB set screws better than any other screwdriver. So I must dig one out. I'm sure that we must have one or two of them somewhere. You never know, I might have to take that bottom off with its 100 screws. You can't even see me unscrewing it. It's the trouble with the bigger sets. Right, we'll pop the top off. Apart from the screw which is in the top. So I've got 10 minutes before I go and do some shopping for one of the elderly parishioners. And let's hope it hasn't been messed about with. Or messed about with too much is probably the... Well, it looks pretty immaculate. It's just what's gone on with this power supply. We'll be changing all the capacitors in the power supply, and especially the large one there. We've had an additional ferrite bead put there. Well, what they've done is there's normally a smaller rectifier on the printed circuit board, and what somebody's done is to put that in, which is going to be an overkill. You know what? I think it would be neater if we put something back which actually fits. I'll get something ordered. I mean, we're not due to start this till... This is Thursday. You're going to see this video next week, because I'm going to have to order. think what we'll do, we'll get a part ordered, try and get my finger out without losing all the screws, and we'll do all the tune-up on an external power supply. So they've put in a BR252, which I'd have to look up, but the point is we don't need to do that. We take the power supply board out, change the capacitors. Chances are the original rectifier failed because the capacitors were getting a bit dodgy. Always possible we've got something suitable in stock. As long as it's above 2 amps, we're fine. Well, it's been nicely done, but I think that somebody's missed the thing here, that it's the capacitors that needed changing on the power supply, and that's probably what had blown the original one, if indeed that is what's happened. And we've got an absolute dry joint of all dry joints. Just zoom the camera in. The centre pin of the transistor, I can't see has any solder on it at all, and that's not much better. So what's the transistor they've put in? BD203. Well, the trouble is I don't have a circuit diagram of the power supplies used in these, so you've got to do some assuming. I could take ours apart, but there would be a fee for doing that. So I think the first thing we'll do is pull out these wires. Just about cleared those up. So I'm going to get those two capacitors changed because they're going to need it, and then we'll get that big one changed, and we'll come back to the video and we'll see what I've come up with. So moving forwards exactly 1 week, it's now the next Thursday because we had the Easter holidays. In the meantime, I did order the correct bridge rectifier, and that has arrived yesterday. So that will fit in, hopefully, properly. Which I've done the capacitors. There's the awkward one down there, and then the ones on this subboard. I'll pause the video because this needs more than 2 hands. Okay, it's all back together. It's time to plug it in and watch it blow up. Now, the customer sent me the right fuse for this, and I've mislaid it. It's supposed to be 630 milliamp. I've put 750 in, so I'm hoping we'll find that. Right. What I really need to do is make sure I've got a multimeter handy. We'll monitor the voltage. Not that there should be any change really in how it was set, but you don't know how it was set. So, presuming the chassis is negative earth, I think we'll just set that crocodile clip lead up. At least these base stations switch the mains. Is that in the wrong position? Must have been. Okay, well that's not right. So is it? Yeah, there we are. So it's not chassis to earth. So that's a bit high, 13.9. So just pop that down. So that'll do me. 13.76 is about as near as we're going to get it. So we'll now get it connected up to the test equipment. So you saw the small bridge rectifier. It's not quite what went in before. So what I've done is to put two large washers under there so that it can dissipate its heat onto the heatsink. That shouldn't actually be necessary. It should be quite adequate for it to be in free space, but I know that this should be bolted down. I don't know how many amps the original ones are. It's one of these obscure things, but that is 2 amps, and there's no way this is ever going to draw more than 1.2, so we're okay. Now, where am I? Oh yeah, we need to connect it up to the test gear. Disconnect that meter. Yeah, need to use that for the VCO shortly. And he sent a mic with it. So one of these tubs we use for putting screws in, it's gained a visitor. Let's put against something contrasting. I'll pause the video while I'll just chuck him outside. Right, so as usual on this chassis we'll use the Amstrad manual, though I will hasten to add this is a Cybernet 002 chassis. It's not the Amstrad chassis, but I understand what people mean. So procedure, let's put the camera back to its normal position, because that doesn't look like its normal position to me. That's better. So we don't do number 1, we do number 2. So on channel 1, a bit of dirt on that channel selector switch, but it's probably not being used for donkey's years. They usually sort themselves out. So it's capacitor 9 and ground. Capacitor 9 and ground. So we'll tell you what, we'll use the red crocodile clip lead for negative. That seems totally logical, so we'll do that. We know that's ground. We'll put the red to the black, like you'd expect. And capacitor 9 is there. So what do they ask you to do? So in receive they expect you to get 2 volts. Where is my phosphor bronze twagger? Oh well, no, we'll use this one. You don't do the VCO on anything with this chassis. You end up with channels dropping out. So there we are, 2 volts. And then in transmit, they expect you to have 2 volts as well. Got 1.36. So this time it's the trimmer capacitor. So I'm glad I did that. It's about as near as we're going to get that. Go back to receive, it's still 2 volts. Go back to transmit. Now, as they don't tell you to do this, but I'm going to... Okay, so let's move on. And we'll tune up the transmitter. So we're looking at this coil, this coil, this coil, this and that. And hopefully that hasn't been messed with. And we will get picture in picture on. And the radio is doing 3 watts on channel 1, so I better get to channel 20, where it's doing 3.2 watts. That's 3.3. A bit tight. No, it's not going to go above 3.3. Tell you what, we'll adjust that ballast resistor a bit. I find this out quite often with the base stations, to be honest. Now I have a selection. And I think you've seen what happens when this is removed. The radio does most of its power on aircraft band. Well, I'll pause the video while I do that. Right, so moving on to the other part of the transmitter. Let's see what the power output meter's saying. It's swinging right across, and it needs to be in the centre of the red zone. So the preset for that is there. Centre of the red zone it now is. Deviation. Let's see what it's doing straight off the as it's come. 1 2 1 2 1 2. Either I'm not tuned in or it's not doing anything. 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2. Don't think it's doing anything. Let's listen on the monitor receiver. I don't know where its aerial is. Testing 1 2, testing 1 2 1 2 1 2. It's not transmitting any audio. It's got a mic gain control, that might help. Testing 1 2. It does help. 1 2 1 2. Right, we'll get back to the deviation meter. One, two. Well, I'll just change scales. What are we actually doing? Wallow. It is doing 6 kilohertz. So it's potentially transmitting on 3 channels at once. So pop the deviation down. One, two, wallow, 1 2. Actually, you can just give it a fraction more. One, two, wallow, 1 2. Yep, we've got it. So it wants to be between 2.2 and an absolute maximum of 2.5. So that's now sorted. And that now means we can move on to the receiver. So we've brought the power up, haven't we, from 3.2 to full 4 watts, and just feeling the temperature of that bridge rectifier. That feels all right. Okay. So we need to plug the extension speaker into there. Set the signal generator up for 2779125. Channel 20. And we can hear it already at 1. There's 0.3. I think it's capable of a bit better than it's doing. So we'll start with the oscilloscope. We'll put S9 equivalent signal on of 100 microvolts. Turn the bench light off. And we'll adjust the detector. It's a funny waveform. What's that? Why is that? I'll adjust it on the oscilloscope under this strange circumstances. If I recall, it's that one there, but I'm usually wrong. It is that one there. That's way out. No wonder I needed to adjust the oscilloscope. There we go. Turn the volume down, and we'll look at the cyanide meter. So we'll drop the signal till we get about 4 dB. We'll start with the front end, T5. So the meters, the more to the left it is, the better. that's to the right. And that's about the peak. To the right, to the left. It's about where it should be, where it was. And that's about where it was. Now these IF ones, we need a bit more signal for those. So we'll go to about 10 dB. Interesting, it suddenly, I took my tool out of there and it was suddenly worse. Let's use the ceramic one. Right, it looks like we've got a bit of hand capacitance. What I'm going to do, we're going to put the bottom back on. It does help when you put the bottom on because it's got feet on it. And then it's not enough strange angle on your bench. Better than some sets where you've got to take about 16 screws out of the bottom. To be honest, I deserved a coffee about half an hour ago, but I'm so close to finishing this that we may as well finish it. See whether that improves the hand capacitance effect. Well, it's come straight on with 12 dBs plus. So what's affecting it? Let's do it with my left hand. Well, with my left hand I've got a slightly better reading, so let's see what we've got. They're quite sensitive usually. So for 12 dB we've got 0.5 of a microvolt. For 10 dB we've got 0.45 of a microvolt. And for 20 dB, if it ever does it, I look to have got about 1.5 microvolts. We'll just see whether we can get that front end a little bit better. Just temporarily put the lid on. See whether put a screw in for now. Definitely got a hand capacitance effect, hasn't it? Oh, that's where the customer's fuse is. What a daft ha'porth. Oh, that's the original fuse, 2.5 amp, which is wrong. Anyway, I've put in 700 milliamps, so that'll do. I wonder if the earth's off in the plug. I'll tell you what, I'll get the pat tester. Right, let's see what happens. Let's get the clamp on there. And let's get the mains lead plugged in. Now the customer's going to change the plug on. Ah ha ha! Ah ha ha ha! Customer's going to change the plug on this, he said. You know what? I think we're going to be changing the plug. Now then, does that look like the earth's off in the plug? It's got a 13 amp fuse, which is wrong. You know what? No, the earth isn't off in the plug. It's off somewhere, isn't it? So in that case, we'll let the customer change the plug as he said. He's a licensed amateur, so he should be alright. Just that plug, that fuse needs changing to 3. So we've got a problem somewhere with no earth. So let's put our clamp onto where the earth comes on into the radio. Maybe a bonding problem. So that does want addressing, don't get me wrong, but I think he would prefer to change the plug because he's probably got one lurking. Let's try again. Yeah. So it's not bonding to the chassis properly. Okay. That's why we check these kind of things. It was a strange phenomena. It's probably just a matter that this is loose. It is. Simple as that. I'd have a nut runner that fitted, but our nut runner's a BA. I'm probably too near to retirement age to buy more nut runners. Right, that's tightened it up. So let's see whether that's fixed it. So put the clamp on there just like we did first time. That's it. So this is doing it at 500 volts, by the way. Excellent. So now when I plug it in, we hopefully won't have a strange thing happening. He says with his fingers crossed. And if it is improving the earth. I don't know why that is. 0.4 of a microvolt if I touch it, 0.5 if I don't touch it. How bizarre. Well, I won't put it on the aerial. That's well and truly earth. The aerial actually has an earth rod into the ground. So I recommend anyone using this has an earth rod into the ground for the aerial. So I don't know why that is, but at least it's now passed its test. So it was just the earth bonding on the chassis which was loose for some bizarre reason. So we need to set the S meter next. So we'll put S9 on the radio. And you'll see that's reading plus 30 in a bit. So we'll just pop that down. Trying to remember which one it is. I think it's that one. I've got the manual in front of me, but I'm still guessing. It is S9 for the 100 microvolts. And we just need to check the squelch. So I'm going to turn the squelch to full on the radio. Let's put the picture-in-picture back and we'll put the attenuator controls on for you. So we can see that's 0.3 of a microvolt. I'm just going to advance this. I want the squelch to come in at 100 microvolts. 1, 3, 10, 30, 100. Look at that, just where it should be. Now at the sensitive end of the radio, we'll park the signal generator at 0.3 of a microvolt and we'll turn it to standby. That's what the red light come on for, to tell me it's on standby. So now we'll turn the squelch down on the radio and set it to threshold. Threshold is when the background noise just disappears. So it's at its most sensitive. Let's switch the signal generator on. And it's coming in straight in at 0.3 of a microvolt, which is fantastic. It's cut out at 0.2. .29 coming in. Try that again. 0.29. Dropping out at 0.224, 0.21. That's a really sensitive squelch, which normally lets these sets down. So that's it. We're done. So we will go over to putting the lid on. Just for now, for speed, I'll just put one screw in. We're getting on the air test done with Mr. Chippy. The customer's waited long enough, waiting for parts. And as I'm only doing 1 CB a week whilst we've got this colossal organ restoration underhand, in hand. I'll just put that one in for now. Switch the signal generator off. And the other test equipment, save what bit of electricity we can save. So here we go, let's have a flick through. $19, Roger. 20. So we've got this channel selector switch. The digits are a bit iffy with it. Roger. So we're on. It's Friday. It's about 10:30 in the morning. So hopefully everybody's at work and not chatting on the CB. But there we are. That should work well. And what I'll say to the customer, well, the customer hopefully will see this. The only way out of that is to drill some holes with a vacuum cleaner as well, so the bits don't go inside, into the channel selector switch top, and spray service cell switch cleaner in there. I don't like to do that, because any bits do get inside. Well, that's it, isn't it? So it's a bit risky, and I think, if this has probably been used in an environment where people have had cigarettes, well, that's one of the reasons that can play up. But it doesn't affect the performance of the radio, and but it can be. It's just some of the channels. When I set off with this, it was even messing about on channel 20. Well, it isn't messing about with channel 20 now. So I'm sure if we work it around, it'll self-clean, because they do. It'll ride up with wear, as the shop would say. Anyway, we'll leave it on monitoring. And there's your Harvard H407 base station from 1981. They're $129.99, and that's, although it's had some messing about with that deviation control, the strangely powerful bridge rectifier, it works absolutely great. So there we are. So thanks for watching.